So this is going to be a review of questions 17 through 19 on practice test 6 of the SAT. When designing a stairway, an architect can use the riser tread formula 2h plus d equals 25, where h is the riser height in inches and d is the tread depth in inches. For any given stairway, the riser heights are the same and the tread depths are the same for all steps in that stairway. The number of steps in a stairway is the number of its risers. For example, there are 5 steps in the stairway in the figure above. The total rise of a stairway is the sum of the riser heights as shown in the figure. So number 17, which of the following expresses the riser height in terms of tread depth? So all of these equations are just this equations, but h is isolated, so we'll just isolate h. So 2h plus d equals 25, or 2h equals 25 minus d, or h equals 1/2 times 25 minus d, and that is b. Okay, pretty simple. 18. Some building codes require that for indoor stairways, the tread depth must be at least 9 inches and the riser height must be at least 5 inches. According to the riser tread formula, which of the following inequalities represents the set of all possible values for the riser height that meets this code requirement? So h is the riser height, right? So, and the minimum value of h is going to be 5. And here, the maximum value of h is 5, so that's not true. Here, the minimum value of h is 8, so that's not true. So it's either b or c. So for c, there's an upper value of h. So how do we find if there actually is an upper value? Well, let's just look at this equation. 2h plus d equals 25. And the tread depth must be at least 9 inches. So d, the minimum value of d is 9. And in this equation, if d is larger, then h is smaller. So if the value of d is minimized, then that gets us the maximum value of h. So let's just plug in 9 because that is the smallest possible value of d. So 2h plus 9 equals 25, or 2h equals 16, or h equals 8. So 8 is the maximum value of h, so we know that it's c. And 19. So I read the SAT explanation for this, and I didn't really understand it that well, so I just made up my own explanation. So an architect wants to use a riser tread formula to design a stairway with a total rise of 9 feet, a riser height of between 7 and 8 inches, and an odd number of steps. With the architect's constraints, which of the following must be the tread depth in inches of the stairway? Okay, so if the total rise is 9 feet, and there are 12 inches in 1 foot, then the total rise is 108 inches. And there are an odd number of steps, and riser height is h, so 108 over h has to be odd. And we notice because of this paragraph here, and we can just extrapolate that and turn this into this equation, because the number of steps in the stairway is the number of its risers. For example, there are 5 steps in the stairway of the figure above. The total rise of a stairway is the sum of riser heights as shown in the figure. So, if the total rise of the stairway is the sum of riser heights, and the riser height is h, the sum of all h's will become 108, and if there are an odd number of h, or riser heights, that create 108, then 108 over h is odd. So with these constraints, which of the following must be the tread depths in inches of the stairway? So these are tread depths, or the values of d, and we have an equation, so let's just plug these values of d in and see what h is. So 7.2, and we have a calculator. Okay, so we have all the values of h here. So if we have the values of h, and h, or 108 divided by h is odd, we just divide 108 by these values here, and see if it's odd or not. So first off, h has to be between 7 and 8 inches, so it's not A, and it's not D, so it's either B or C. So let's just divide 108 by these values. So by 7.75, that's not an integer, so that's not an odd number. Or now let's do 108 divided by 7.2. And well, that is an odd number, so it's going to be C. And here, there's an example of, you could just plug things in and see what works. So you just want to take as much information you can out of each question and just kind of write them down if you want. And then you just plug in answers. You don't really have to solve for anything because the SAT explanation requires you to actually solve things. But here, you can just plug things in and see what works. And if you're stumped on a question, you can just start plugging things in and see what works. And, you don't have to solve every single question. Obviously, you shouldn't do this for every single question because that's going to take a lot of time. If you could just solve it, then that's usually going to be shorter than plugging in each of the 4 answers. But yeah, you don't have to solve everything. Just plug things in and see if they work. And also, process of elimination, also very useful. Anyways, that was question 17 through 19 on practice test 6, and thank you for watching.